Hello everyone, myself Dipanjan Kormokar. Today I am discussing about the problem which come in CSR exam 2014. You see this problem on the screen, and this type of the problem is come in CSR exam 2012. You can find and check it. And now today I am discussing about the problem which come in CSR exam 2014, and it is the based on the Hammett equation. This well known Hammett equation. And first we know what is the Hammett equation, and then we try to predict the probable answer. Now let's start. Now first we know that what is the Hammett equation. According to the Hammett equation, log k is substituted by kh is equal to sigma into rho, and sigma is called the substitution constant, and the rho is called reaction constant. Now we discuss the briefly what is the substitution constant and the reaction constant. Now this is the benzoic acid, and it dissociated and give the benzoate ion and H plus, and there is a benzoic acid, but there is a nitro or the group which is para position of the benzoic acid. Now it also liberate the H plus, that is the H plus. If we name it's 1 and it's the 2. Now it is we see that the H plus liberation is quite faster in it, because we can predict it from the rotating structure of the molecule, that is the resonance structure of the molecule. And due to this resonance, it is observed that there is a positive charge, and since there is a positive charge, there is a del plus generation which is pulled the bonding electron, that is the OH bond in electron. Since H plus liberation is quite faster, so second reaction is quite faster than reaction 1. So according to the Hammett equation, that is the log k is substituted, and k substituted, that is the NO2 substituted at a para position, and kh there is nothing, means there is a H is equal to sigma into rho. The sigma is the substitution constant and rho is the reaction constant. Hammett assumed that the value of the rho, that is the dissociation of benzoic acid, is 1. And since the second reaction, this can be represented as log KNO2 minus log KH is equal to sigma into rho. And since second reaction is quite faster, so that we can predict that this is quite positive, that is the sigma in rho is a positive quantity. Now according to the Hammett, rho is a positive, that is 1, so sigma value is nothing but positive. And what happen if we introduce a methoxy group at a para position? There is a quite little difference. If we introduce a OMe group, that is the methoxy group at a para position, it donates the electron. Since the electron density, that is the resonance structure of it, we see that the resonance structure, there is the electron density increases, so it cannot pull the electron, so the rate of the reaction, that is the liberation of the H plus ion, is a slow than former one. So there is a slow, so this 3 is slow, so that we predict that log k OMe, that is the methoxy group, by kh is nothing but negative, that is the sigma into rho is a negative. According to the Hammett, the rho value is 1.00, so we can conclude that the sigma value is a negative for the methoxy group, and the NO2 group is a sigma value is a positive. So we can, from there we can conclude the two fact: when the electron donating group is there, electron donating group, that is the OMe group, that is the methoxy group, nothing but, then the sigma value is negative. And when the electron withdrawing group there, that is NO2, then the sigma value is a positive. This can conclude it from here, that is sigma value is a positive when the NO2 group, that is the electron withdrawing group, and sigma values are negative when there is the OMe group, that is the electron donating group. And now we discussing about the rho value. that is the reaction constant value. Now the rho value, that is the reaction constant value. Now from the calculation of the rho value, that is the reaction constant value, we can use our problem, that is this problem. Now from this problem, the first we see that this type of group, that is the aryl group, we take the benzene instead of aryl any aromatic system, and there is a NH2 group, and there is a compound which is the benzoyl chloride. Now it donate the attack, nucleophilic attack, then there is a occur, then liberation of the group, and then we produce this type of the compound are NH 0 of pH. Now this type of the reaction does not occur as a one step. That is a formation of intermediate, that is nothing but tetrahedral intermediate, then liberation of the Cl minus ion. We can show it in one step, but this does not occur in one step. Now if we introduce a NO2 group or any group substitute at of that NO2 group or methoxy group at a para position, what is the rho value? The rho value is the same that we can find here. If there is a NO2 group is a para position, so what happen? The lone pair availability on NH2 group decreases because it undergoes the resonance and it pulls the electron towards itself, so that the nucleophilic attacking tendency of this is decreases very much, so that log K is substituted minus log KH is nothing but negative value. So sigma in rho is the negative, and since if we introduce the NO2 group, that is the electron withdrawing group is there, so you write that the electron withdrawing group, the sigma value is a positive, so sigma value is positive. So what is the value of the rho? Rho value is nothing but negative. Similarly, if we saw that there is a methoxy group in para substituent, the lone pair availability on NH2 group increases, so the attacking tendency of this is very much high, so that rate of the reaction is very much high for this. So for this, log K is substituted minus log KH is positive, that is the reaction is faster, the second reaction is quite faster. So according to this, sigma into rho is nothing but positive. Now you see that there is a electron donating group, so that the sigma value is a negative, so sigma value is a negative, to making the total product positive, so rho value is nothing but negative. So the rho value of this type of the reaction is negative. You can see that the question, there is a 2 rho value which is the negative, there is a 1 rho value negative, there is a 1 rho value is negative, that is rho value is nothing but reaction constant. 2 rho value. Now another type of the reaction, that is the question B. There is another type of the reaction, and we can see this type of reaction where instead of the aryl group, we can introduce a benzene, and that is the phenoxydione and ethyl iodide, and you see that there is a phenoxydione and ethyl iodide. This is similar the type of the reaction of above one. That means if the OMe group at a para position, so it can increase the electron density of the phenoxydione, so the rate of the reaction increases, so the log is substituted by log KH is a positive, and the sigma value is also negative because para substituted, and which is the electron donating group, since rho value is a negative when is the OM is introduced here. When the NO2 introduced in there, just so that the negative charge density decreases, so the rate of the reaction decreases, so the log is substituted by log KH is negative, as the NO2 is electron withdrawing group, so the sigma value is positive, so the rho value is negative. Since there is a rho values are also negative, there is a 1, that is A, and that is B. there is a rho value is also negative, but there is a rho value is also negative. But which rho value is a more negative or more positive, or which rho values are very much high, that can predict we have, because there is only two negative value, and among them there is a also, this is also negative value, rho value, this is also negative value, and we have to determine which rho value is which one, that this or this, or this is this or this. Now this can predict easily if we know the SN2 reaction mechanism. Since this is nothing but SN2 reaction mechanism, so the advantage of is that the reaction occurs in one step, that is the single step, and which is the nothing but RDS step, that is the rate determining step. So we can say that this is the rate determining step, so the rho value is quite high for this. But this does not occur in one step, and this occurs more than one step, and the rho value is for this step is greater, is less. Why this less? Because there is a more than one step, so there is a one step which is the rate of the reaction increases, and there is another step which decreases the rate of the reaction, we don't know, but there is one step, that is the RDS step, which increases the rate of the reaction. So in this case the rho value is very much high, because this is occurs as a SN2 pathway, there is a one step, so the rho value is high, but there is does not occur one step, there is a more than one step, so hence there is a one step which increases the rate of the reaction, another step which decreases the rate of the reaction. Since the rho value is low, since there is a compound 2 where the rho value is high, it is observed that the rho value is high, that is minus 0.99 and minus 2.69, high is minus 0.99, rho value high, so this indicate this, and there is also negative value, but this negative value is this, as sign is negative. What is the magnitude? Whatever the magnitude, the lower magnitude is high value, this lower magnitude is a high value as the negative before it. And what about this? That is the compound C, there is a two positive value, there is a P and S, and what is the product? What is the answer of this? And if we sort out, then we can easily answer it. And for this type of the question, this is nothing but hydrolysis reaction in basic medium, that is hydrolysis in basic medium in NaOH. Now if we just see that this is occurred in the RDS step, that is the rate determining step, that is the formation of tetrahedral intermediate, which is the occur in RDS step, and then the liberation of OET group, that formation of the benzoic acid. Now what happens if we introduce the NO2 group in this position, this pulled electron, so there is a positive charge density increases, nucleic attacking tendency is increases, so the rate of the reaction is high, so sigma rho is nothing but positive. And what is the rho value? Electron withdrawing group, there is a positive, and what is the sigma value is positive, and what is the rho value? Rho value is nothing but positive, because product of two positive give positive. And if we see that when is a OMe group at this position, that is a para position, it increases the electron density of this, so the nucleophilic attacking tendency is very lower. Since log K is substituted, and that is the OMe substituted, minus log KH is negative, since the sigma rho is nothing but negative. Now for OMe group, that is the methoxy group, the sigma value is a negative, and that is the rho value is nothing but positive, because the product of negative value and the positive value give the negative value, as it is the electron donating group, it is a positive value. Now if we see that there is a OH attack occur in here, and this step is RDS step, that is the rate determining step we talked earlier, that step is a RDS step, and so the whatever the rho value is high, because this step or the nucleic attack occur, this is RDS step, since the rho value is high. So there is a row value is a positive and row value is a high, and there is a 2 row value which is the positive, and there is a positive, but this is high. So C is nothing but. So what is the answer? A is R, and B is Q, and C is P. That's match with A is R, B is Q, and C is P. So answer 2 is correct. Other answer seems to be wrong, and this is the answer. Thank you for watching. Have a nice day.